In this short video, I'll be talking about cofunctions of complementary angles. And we'll start out with a question, which is, what is the relationship between the sine and cosine values of complementary angles in a right triangle? So first, let's talk about what we mean by complementary angles in a right triangle. So if we have a right triangle, let's draw that a little bit better. Somewhat better. We have a right angle down here. So this angle, let's call it alpha, and this angle, let's call it beta. These two angles are complementary because their sum is 90 degrees. So complementary angles are angles whose sum is 90 degrees. We can also think of that those angles adding up to a radian measure of pi over 2. So if we're in degrees, we would say those angles add up to 90 degrees. If we're in radians, we would say pi over 2 radians. So in other words, alpha plus beta, or let's say the measure of angle alpha, let's erase. So the measure of angle alpha plus the measure of angle beta is equal to 90 degrees or pi over 2 radians. Okay, so let's think about what the sine value is of alpha. Sine of alpha. What is that going to be equal to? So recall that sine of an angle, let's say alpha, is equal to the opposite side over the hypotenuse. So let's label some of these sides. Let's say x, y, and r. So the sine of angle alpha is equal to the opposite side divided by the hypotenuse. And then let's do cosine of the complementary angle, so angle B or beta. That is going to be equal to, well, cosine is the adjacent side divided by the hypotenuse. So that's going to be x over r. So what we notice is that these ratios are the exact same. So we can write this in a single expression. So sine of alpha is equal to cosine of beta, and those are both equal to x over r. Now this is what's really important, that the sine of one angle is equal to the cosine of that angle's complement. Another way that we'll see this written is that sine, well, let's back up just a hair. What we see is that, well, alpha and beta add up to 90, so we said alpha plus beta is equal to 90 degrees. I could solve for either of these angles, so alpha is equal to 90 degrees minus angle beta, and this is the relationship that we'll see when we're writing this equation. So let's formalize this here on the next slide. So we saw that sine of alpha is equal to cosine of beta, and we had this equation. Solving for alpha, we see that alpha is equal to 90 degrees minus beta. So what I'm going to do is this 90 degrees minus beta, I'm just going to substitute it here. So sine of 90 degrees minus beta is equal to cosine of beta. Similarly, we could say that cosine of 90 degrees minus beta is equal to sine of beta. Now, what this means is, what we'd say about these two functions, sine and cosine, we'd say sine and cosine are co-functions of each other, and co is just short for complementary, so complementary functions. So what does this mean in practice? Well, if we have a right triangle, and let's say I just pick two angle values. Let's say this is 40 degrees, and let's say this one is 50 degrees. So what that means is the value sine of 40 degrees is equal to cosine of 90 degrees minus this given angle, which is 40 degrees. So sine of 40 degrees is equal to cosine of 50 degrees. So sine of this angle is equal to cosine of this angle. we can kind of rearrange that. We can say cosine of this angle is equal to sine of this angle, and so on. So sine and cosine are cofunctions of each other. Now, that is one pair, sine and cosine. We have two other pairs, and it's just the other four trig functions pair up. So we would say that tangent 90 degrees minus some angle beta is equal to cotangent of angle beta. Similarly, we could say cotangent of 90 degrees minus beta is equal to tangent of beta. So tangent and cotangent are cofunctions of each other. And then secant 90 degrees minus beta is equal to cosecant of beta, and cosecant 90 degrees minus beta is equal to secant of beta. So each of these pairs shows which trig functions are cofunctions of each other. And we'll look at two quick examples that help illustrate the usefulness of these cofunction relationships. So first it says, if sine of t is equal to 5/12, find cosine of pi over 2 minus t. Well, remember, the input value in a trig function, in this case the t, this is an angle. So we're saying sine of angle t is equal to 5/12. And then what we want to find out is, well, what is the cosine of this angle equal? Well, we just saw that sine of any angle, we were calling it beta, is equal to cosine of 90 degrees minus beta. Another way we can write 90 degrees is pi over 2. So what we have here is sine t and sine b. It's just saying sine of some angle is equal to cosine of pi over 2 minus that given angle. So because of all of this, what we're going to say is that cosine of pi over 2 minus t, this expression here is equal to this expression here. So because those are equal to each other, these are both going to be equal to 5/12. So there's not really any work for us to do on that one. So we'd say that that is equal to 5/12. And then the second example here, it says if cosecant of 30 degrees is equal to 2, find secant of 60 degrees. Well, we know that cosecant and secant are cofunctions of each other. And 60 degrees, we can rewrite that as 90 degrees minus 30 degrees. And 30 degrees is this angle here. So it's kind of like we have cosecant of some angle, let's call this angle theta, that is equal to secant of 90 degrees minus theta. And so we have 90 degrees here minus that angle theta. So this cofunction relationship, there's not really any work for us to do, so this is just going to be equal to 2. We can visualize this on a right triangle. So let's go ahead and do that. So if you can't conceptualize what's happening with these cofunctions, let's draw this on a right triangle. So, and we know it's a right triangle because when we're dealing with trig functions like this, we know that geometrically we can represent these with a right triangle. Okay, so the first thing for us to remember is, well, what is the cosecant function? What ratio is the cosecant? Well, I sometimes have a difficult time remembering what cosecant is, but I know that it's the reciprocal of sine. So sine is equal to opposite over hypotenuse. And cosecant is just the reciprocal of the sine function. So this is going to be hypotenuse over the opposite. Similarly, secant is the reciprocal of cosine. So cosine of some angle is the adjacent side over the hypotenuse. Secant is the reciprocal of that. Okay, so these are the two ratios we're going to need over here when we visualize this. So first of all, we have cosecant of 30 degrees. So 30 degrees is up here. Cosecant is going to be the hypotenuse over the opposite side. And because the hypotenuse over the opposite side is equal to 2, we can just write the hypotenuse over the opposite side as a ratio of something that's equal to 2, 2 over 1. Now let's look at secant of 60 degrees. Now we're going to stand at 60 degrees. Secant, we said, is hypotenuse over the adjacent side. Hypotenuse is 2, the adjacent side is 1. That confirms that these are both equal to 2. So if we can't remember every time what the cofunction relationships are and how they work, it may be useful to confirm what we initially think by sketching out a right triangle like this.